Welcome back. Mr. Greenstein's Geometry here. We're talking about the tangent ratio. This is Chapter 9 for Part 2. And we specifically were talking about how the tangent of an angle is equal to the ratio of the opposite side length over the adjacent side length. So we're going to use this to actually do some calculations here. We're going to find the tangent ratios for these triangles on this page. In this particular case, I've got a RST is my triangle, and the tangent of angle R, whatever that angle is going to be equal to the ratio of the opposite side over the adjacent side. So if I was to write this, I would write this as 18 divided by 80. Which is another way of saying 9 over 40. When I look at the angle S, I look for the opposite over the adjacent. So the opposite over the adjacent is going to be 80, and that's going to be divided by 18, which is the same thing as saying 40 over 9. So that's the tangent ratio for that triangle. Now let's take a look at this triangle over here, JKL. With JKL, I'm going to take the tangent of this angle. That means the opposite over the adjacent. So the opposite over the adjacent is going to be 15 over 8. Whereas with J, the opposite is going to be 8. So 8 over 15. So the tangent ratio is going to be 8 over 15 for the tangent of J. Let's calculate this problem here. We have an angle in this triangle of 32 degrees. And we know that the tangent of an angle is equal to the opposite over the adjacent. So let's just write this out. We're going to have the tangent of 32 degrees is equal to the opposite, which is 11, over x. If I multiply each side by x and divide each side by the tan of 32, or the tangent of 32, I get x equals to 11 over the tangent of 32. You can take your calculator and plug in these numbers, and what you will get is that x is going to be equal to 11 or 17.6 approximately. And that's the distance that is for x here. And all we knew was that we have a right triangle, we have an angle, and we have the opposite side. And by using the tangent ratio, we were able to come up with the third, or the other side, the other leg. Let's try this for the next two problems. I have this problem over here, this triangle. I have an angle 61, and then one leg is x and the other leg is 22, so I want to find out what x is. So I'm going to write this out. I have the tangent of 61 is equal to, and sometimes I don't put the parentheses around the 61, that's okay, the opposite side, which is 22, over the adjacent side. And when I multiply this out, I come up with x is equal to 22 over the tangent of 61. Tangent of 61. And then that works out to 12.2 approximately. Let's look at this second triangle over here. I have an angle 56, the opposite side is x, and the adjacent side is 13. So I'm going to write out the same tangent ratio, tangent of 56, and that is equal to the opposite, which is x, over 13. So when I multiply each side by 13, I get x equals 13 times the tangent of 56. And when I work that out on my calculator, I come up with approximately 19.3. So that's the length of that side x is 19.3 by using the tangent ratio and my calculator. Let's take a look at a real problem. Sometimes I can't climb to the thing that I want to measure, in this case a tree. I want to find out what the height of the tree is. But down here I have some tool, let's just pretend that I have a tool that can measure this angle. Now I'm standing here and I can measure this is 59 degrees here, and I'm standing on a flat plane with the tree, so the tree makes a nice right angle, and I know that this is 45 feet from where I'm standing to the tree's base. I want to find what the height of the tree is. So I'm going to use the tangent ratio to calculate that. And the way that I do that is I say the tangent of 59 is equal to the opposite, which is the height, divided by the adjacent side, which is 45. And then when I multiply this through, I get that h is equal to approximately, or let's say first it's 45 times the tangent of 59. Oops, I can't get my 9 in there, sorry, that's 59. And when I use my calculator, I come up with that h is equal to approximately 74.89 feet. Without even climbing that tree, I was able to calculate its height. And I did that using the tangent ratio. We're going to take more of a look at this in next time that we meet in class.